Okay, this is a video for 3-1 trigonometry. 3-1 is titled Radian Measure, and I'm just going to go through the notes with you. It's fairly easy. You're just doing a little bit of conversion and drawing some triangles. So the first thing we need to do is define radian. So an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length, because I can't write as fast as I can talk, sorry, equal in length to the radius of the circle, has a measure of 1 radian. Okay, so picture to go with. Okay, if this is our circle, and it's supposed to be centered, but let's pretend. Okay, we have an angle, we have a radius, and then this is the arc. So what it says is that the arc is going to be equal in length to the radius. So this measure is going to be the same as that measure. Okay, so we're going to do conversions. So first conversion. Okay, so these are examples. We're going to first convert between degrees to radians. Okay, so when you are converting degrees to radians, all you really do is multiply by pi over 180 radians. So for example, if I have, so make sure I'm still on the paper, 300 degrees, and I convert that to radians, I multiply by pi over 180, and I end up with 300 pi over 180. I lowest term my 300 and my 180 and end up at 5 pi over 3 radians. So there is my conversion from degrees to radians. Okay, next example, 240 degrees, again, times pi over 180 becomes 240 pi over 180. We lowest term, and that becomes 4 pi over 3 radians. So not too bad. So if they're positive numbers, just multiply by pi over 180 and then lowest term. Okay, if they're, back on the paper, let it adjust. Okay, so next example, if they're negative degrees, really not any different, times pi over 180, so negative 225 pi over 180 degrees. Again, we just lowest term, and we're going to get, crap, forgot to solve that one out. Okay, 225 divides by 45, so 5 pi, 180 divides by 45, 4, so minus pi over 4. Okay, so if there is a degree, minute, and second, so 30 degrees, 15 minutes, 45 seconds, what you really need to do is convert that to a decimal and then do the same thing. So, or use your fancy calculator and just divide out the 30 minutes, 15 seconds, or 15 minutes 45 seconds and divide that by the 180 degrees. So either way, you'll end up with a decimal answer, and you're going to do the decimal times pi divided by 180. So in this case, final answer would not have a pi in it because it does not come out even. So either use this on the calculator and just divide it, multiply it by times pi and divide it by 180, or convert this to a decimal and then multiply it by pi and divide it by 180. But your final answer in the case of this or the decimal would end up being just a decimal radian. Okay, and I guess the only other option would be is if they don't give it to you in minutes, seconds, or minutes, degrees, minutes, and seconds. And again, these are actually approximate values because of the way that you're solving. So this is not an actual, this is just an approximate. So the same thing if you had just an ordinary degree starting. To convert it to radians, you would just do 165.2 times pi over 180, and again, just do this entire thing out on your calculator. 165.2 times pi divided by 180, and then just give me the decimal answer. So the only time you leave pi in the answer is when you're dealing with all whole numbers. Okay, so that was converting degrees to radians. Okay, I'm going to move the paper up. And now we're going to go the other direction. So now we're going to go and convert radian measurements to degree measurements. Okay, and all you're going to do is do the opposite of what you did before. So you're going to multiply by 180 over pi. So, for example, if we start out with 7 pi over 3 and I want to convert that to a degree, I multiply by 180 over pi. Okay, the pi's cancel. I do 7 times 180 divided by 3, or I can do 180 divided by 3 times 7. I mean, however you solve this out, please don't forget to cancel your pi's. And final answer would be at 420. Same thing with something like 5 pi over 8. We multiply by 180 over pi. What happens there is 180 times 5 is 900. The pi's cancel over 8. So you could either lowest term both of those or give me a decimal answer. So either 225 over 2 degrees or whatever that divides out. Okay, again, when you're dealing with whole numbers, I'll do one more, so pretty much let it focus. Okay, so again, if we're going from radians to degrees, 2 pi over 3 times 180 over pi. Again, the pi's cancel. 2 times 180 divided by 3 is just going to be 120 degrees. Okay, then you'll have approximate answers if you have decimals. So if they give you 3.56 radians, okay, you're going to convert that the same way. 3.56 times 180 over pi, but since there are no pi's to cancel, you're just going to do 3.56 times 180 and divide it by pi. So 203 point, let's see, depends on calculators, and I guess if you do the 3.56 and the 3.14, if you go across the top and then divide, or you do this divide by that, you can really get a variety of answers, and And actually both of these would work because it really is just a rounding issue. So this again is an approximate answer because of the fact of we're dealing with the pi or the 3.14. Okay, another thing is if no unit is given. Okay, please assume radians. So if you do not see a degree symbol, that means please assume radians. Okay, the next part of this lesson, we're going to work on using finding trig functions using radian measure. Okay, so for example, if I wanted the sine of pi over 3, again, if you look on your unit circle, or we convert pi over 3 times 180 over pi, it's really 60 degrees. So if I want the sine of 60, I'm going to draw my triangle, 60, 30, right angle. Okay, I know the pattern, 1, square root of 3, 2. So if we're standing here, opposite, adjacent, and hypotenuse, so sine is always opposite, square root of 3 over 2. So you're going to use your triangles and your conversions to end up solving and finding the trig function. Okay, next example. Okay, for example, we're finding the cotangent of 4 pi over 3. Okay, so you can use your unit circle or convert to degrees, but you are going to need reference angles, so it may be easier to convert to degrees. So 4 pi over 3 times 180 over pi. 4 pi over 3 converts to 240 degrees. So we're going to do the cotan of 240 degrees, and that's what we're going to find. Okay, if we're on our unit circle, 240 degrees is going to take us past 180, so it's going to be down in quadrant 3. Okay, if we do our unit or our reference angle is going to be the 240 minus the 180. So it's going to be a 60-degree reference angle. Again, we fill in the sides. This would be our 30, so our 1, square root of 3, 2. This is to the left and this is down, so those are both negative. So if we're looking for our cotangent, again, tangent is opposite over adjacent, so cotangent is going to be A over O. So if I'm standing on the 60, this becomes the opposite. This is our hypotenuse. This is the adjacent. So if we're doing A over O, we're doing negative 1 over negative square root of 3. Okay, and again, we have to rationalize that. So negative divided by a negative, and then times square root of 3. So square root of 3 over 3 would be our final answer for cotan of 4 pi over 3. Okay, let me do another example. I just want to make sure there's plenty on here so you can try the homework. Okay, we're going to find secant of negative 3 pi over 4. Again, if you do your conversion, you're doing the secant of 135. And that would be a negative 135. So from there, if we do the, let me just check my numbers, 3 times 80. So that's a negative 135. Okay, again, so if we're on our unit circle, okay, we go our negative 135, we're going to go past the 90, so we're going to be in here. Okay, our reference angle is going to be right here. So since this is halfway around is 180, I'm just going to take the difference, 180 minus 135. So this is going to be a reference angle of 45. Okay, our pattern we know there is 1, 1, square roots of 2, a negative 1 and a negative 1. Okay, and we know that secant is the reciprocal of cosine. If cosine is a over h, then secant is h over a. So our secant of negative 135 is going to be hypotenuse over adjacent, so negative square root of 2. Okay, last example, only because it doesn't really involve a triangle, I want to go over this. Okay, so if we're going to find the cotangent of 5 pi over 2. Okay, if we convert our 5 pi over 2 times 180 over pi, okay, the pi's cancel, so 5 times 180 divided by 2 is 450. So we are looking for the cotangent of 450. Okay, 450 is going around the circle too many times, so I'm going to do 450, take away 360, and I'm left with 90. Okay, if I'm on a unit circle and I go 90 degrees, I'm at 0, 1, and cotangent is the reciprocal of tangent. If tangent is opposite over adjacent, then cotangent has to be adjacent over opposite. And so we can't do that because we're not on a unit circle. So we are going to look at this and know that it's going to be okay, hang on. Sorry, lost my place in my notes. So we know that we can't use adjacents and hypotenuses, so we are going to have to use the cotan to be x over y. So in this case, x is 0 over 1, so answer is going to be 0. And I'll explain that more in class on Thursday if we have trouble with that part. Okay. Okay, I'm going to stop there. I'm going to assume that you should be able to get started on your homework then, because you're really doing mainly conversions and then working on coming up with values. So the homework for 3-1 is going to be on page 97, and you are going to try 6 to 78 multiples of 3, so 6, 9, 12, 15, and so on, all the way up to 97. Conversions are all the way up to 54, so you should be able to at least get through 54 before we get back together on Thursday.